Sorry, I had some background noise. Let's go ahead and pick up where we left off. So let's do a spanning tree, and let's get some context sensitive help. Okay, so I think I need to go into interface. Okay, so we need to go into interface configuration mode before we do anything. So let's do an interface fast Ethernet 0, 1. Okay, perfect. Now let's do a spanning tree cost of 100. Perfect. Now let's do a, what is the spanning tree state of switch B's fast Ethernet 0, 1's interface? Well, it should be an alternate port now. So let's do a do show spanning tree VLAN 1. And as we can see, okay, yep. So it's going through the learning state now. But as we can see, our fast Ethernet 0, 3 interface is now our root port. So now traffic will go from switch B to switch C. And then, well, it'll go from switch B to switch C to PC3 if PC2 and PC3 wanted to speak to each other. So let's give an up arrow now, and we can see that our fast Ethernet 0, 1 port is now an alternate or blocking port. So now to prevent loops, switch B is going to block this port right here. So that's what we want to see. So let's move on to task number 3. It says configure port fast and BPDU guard. In this task, you observe changes caused by port fast and BPDU guard. Okay, so that's always good to go over. By default, when a switch is powered up or when a new device is connected to a port on a switch, what spanning tree state does the port transition through? Well, it has to transition through the listening and learning states, and that's to prevent a layer 2 loop from occurring. So it has to send out its BPDUs, receive those back, and then from there determine, the port cost of that port. If that port is, the best root cost, it'll be the root port. If not, then it just basically has to make its decision what type of state it's going to be in, and it transitions through the listening and the learning state. So for question number 2, it says, what can you do to cause a port to switch immediately? What can you do to cause a port on a switch to immediately transition to the forwarding state? So we can configure port fast to allow a port to immediately transition to the forwarding state. You need to be careful though and make sure that it is an access layer switch connected out to an actual host. You do not want to put port fast between switches, because if you do, that could cause a layer 2 loop. So they should always be configured only on access ports, or port fast should only be enabled on access ports, and those connect out to PCs. So it says when BPDU guard is enabled on a port, what occurs when the interface? Okay, when BPDU guard is enabled on a port, what occurs to an interface when a BPDU packet is received? So it'll go into the air disable mode. So it's going to basically shut down that interface to prevent a loop from occurring. And then usually you would have a notification be sent out to some type of network admin letting you know that a BPDU was received, and they can basically check that interface and see what happened from there. So it says, what is the purpose of BPDU guard and when is it typically used? BPDU guard is usually enabled on access layers switch ports. So if a switch is connected to a port that's within BPDU guard, it's going to prevent a layer 2 loop from occurring. So as soon as it receives that BPDU, like I said, that interface will be shut down, and that's just going to prevent loops from occurring. So what command can you use to determine the operational mode and administrative mode of a port on a switch? I think you use show switch port interface. Let's do a show interface status. Let's do a end right here, and let's do a show interface status. Yeah. So you can see the operational mode, I believe. Okay, let me move my iPad. So no, I don't think it's that one. because it says the operational mode and administrative mode. Let's see what command this is. So it says show interfaces switch port. Okay, so let's get this command right here. Let's do a show interfaces switch port. Okay, so we can see our administrative mode is trunk. We can see our operational mode is trunk as well. Okay, we can see that we're using .1Q. Perfect. Negotiation of trunking is on. Okay, so it has some very good information within this output. And now it's with the Fast Ethernet 01 port. We can see that the Fast Ethernet 02 is actually a static. It's a static access port. So it's an access switch port instead of a trunk port. Okay, that's some good info to know. All right, so it says, what is the administrative mode on a 2950 switch? The default administrative mode. It should be, I think it's dynamic desirable, if I'm not mistaken. Yeah, so it says right here, dynamic desirable is the default administrative mode of a 2950 series switch. It says this means that ports with this administration mode connected to neighboring switches will be operating as trunk ports unless a configuration on the neighbor switch prevents trunking. Okay. All right, so let's move on. On switch B's Fast Ethernet 01's interface, enable BPDU guard and observe what occurs when a bridge protocol data unit is detected by BPDU guard. So we're going to go on switch B. We're going to configure this Fast Ethernet 01 connection right here to switch A with BPDU guard enabled. And basically it's going to shut down this Fast Ethernet 01 interface connection as soon as a BPDU is received from switch A. So that's what's going to happen. But let's go ahead and just do the configuration. Let's go into configure terminal, conf T for global config. Let's go into interface Fast Ethernet 01. And let's do a spanning tree BPDU guard. Okay, BPDU. Okay, maybe I'm not doing something right. Spanning tree. I think I need to do port fast. Port fast. Do I need to do port fast? Spanning tree port fast? No. Okay. Oh, it's just spanning tree BPDU. I thought I did that. BPDU. Oh, okay. BPDU guard. And we need to do enable. Got it. Okay. So we can see right here, we just received a syslog message. It's basically disabling this port and putting it into air disable mode. So if we do a do show interface status now, we can see that our Fast Ethernet 01 connection is in the air disable mode. So it was disconnected because a BPDU was received on the interface where BPDU guard was enabled on. All right, so it says on switch B, issue the appropriate show command to display the status of the interface, which we just did. It says on switch B's Fast Ethernet 01 interface, explicitly disable BPDU guard. So let's do a spanning tree BPDU guard. Let's just do an up arrow to bring that back, and let's just put disable. Perfect. All right. So did switch B's Fast Ethernet 01 interface come back up when you disable BPDU guard? No, it did not. We have to re-enable it manually, so we have to do a no shutdown on this interface. So it says enable switch B's Fast Ethernet 01 interface. So let's do a no shut to bring this back up. And let's do a do show interface status just to confirm. Okay, so it didn't come back up. So let's do a no shut one more time. Okay, let's do no, we got to do a shut first. We have to shut it down first. That's right. And then do a no shut. Now it's back up. Now let's do a do show interface status. And we can see now that we're back up and connected. So perfect. All right. Question number 12. On switch B, administratively shut down interfaces Fast Ethernet 01 through 4. So Let's give an exit. Let's do a interface range fast Ethernet 1 through 4. All right. Preceding commands with do enables you to issue privilege exec. Yeah, we know that. So basically put, if you're above privilege exec mode and you need to access privilege exec mode commands, just put do in front. Okay. On switch B, enable interface fast Ethernet 1 through 4, and then immediately issue the do show spanning tree command to observe the spanning tree state transitions on switch B's fast Ethernet 4's interface. Issuing the do show spanning tree command enables you to view the output quickly without needing to change exec levels. Okay, so we're going to enable all of these. So do a no shut, and then it wants us to immediately do a do show spanning tree. So let's no shut. Let's do a do. Okay, did it? Okay, so I didn't shut them down. Let's shut them down because I did a no shut. Okay, and let's do a no shut now. And let's do a do show spanning tree. Okay, so it wants us to look at the fast Ethernet 04 connection, which is on switch B, is this connection out here to PC number 2. So it has to go through we want the fast Ethernet 03 and 01 interfaces to go through the listening and learning states to prevent layer 2 loops, because they are connected to other switches. But this fast Ethernet 04 connection, we do not want it to transition through the listening and learning states, because it delays this PC from getting on the network and being able to browse the internet. It has to wait basically 30 seconds to transition through the listening and learning states. And that can be, it can prevent this PC from getting a DHCP IP address. It can just slow down the user from accessing the internet as soon as they boot up the PC. So you want to enable port fast on this port to bring it up as soon as they cut on their computer. So let's go. It says on switch B's fast Ethernet 04's interface, enable port fast and BPDU guard. So that's what it wants us to do. Let's do an exit, and let's go into interface fast Ethernet 04. And let's do a spanning tree port fast. Okay. And let's do a spanning tree BPDU guard enable. Okay, so now we did BPDU guard enabled on this. So if a switch is connected right here, the interface will be shut down, or well, not shut down, but air disabled. So it says on switch B administratively shut down fast Ethernet 01 through 04. So it's going to make us do the same thing again, and now we should see that the fast Ethernet 04 interface should transition directly into the forwarding state after it is shut down. So let's do a shut here, and let's do a no shut, and let's do a do show spanning tree. And we can see right here that our fast Ethernet 04 interface is already forwarding. It doesn't have to transition through the listening and learning state. So that's what we want to see. So it says with port fast enabled, switch B's fast Ethernet 04 interface should immediately transition to the forwarding state when the interfaces are enabled. On switch B, enable the fast Ethernet 01 through 4 interfaces and issue the do show spanning tree command to observe the spanning tree state transitions that occur on switch B. So we just did that. All right, so task number 4, compare PVST, so per VLAN spanning tree, and MST. In this task, you will create 2 VLANs and use various commands to determine the root bridge for multiple VLANs. So the first question is asking, it's saying, what switch is configured as the VTP server? So let's issue some commands to figure that out. Let's do a show BTP status. Okay. So we can see right here that this switch A is operating as the server. Let's do a couple of show commands on the other switches. Let's do an N. Let's do a show VTP status, not spanning tree. So switch B is operating in client mode, And let's do a show VTP status here. Oops, status. And switch C is also acting in client mode. So switch A is our BTP server. So we want to do all of our VLAN configurations on switch A so they propagate out to our client devices. And it looks like they're all in the same BTP domain using Boson. So that's perfect. The VTP domain name is Boson. So we can see that right here. Okay. So on switch A, create VLAN 10 and 20. So let's do a configure terminal to go into global config mode. Let's do VLAN 10. And do we need to name it? It doesn't say we need to name it. Let's do a VLAN 10 because I didn't see it come up in my syslog. Okay, yeah. It says it's added. All right, and let's do a VLAN 20. Let's do a VLAN 20 again. Okay, now we see it in our syslog, so it's added too. Let's do a do show VLAN brief, just to be sure. And we see our VLAN 10 and 20 VLANs are now within our VLAN database. So that's what we want to see. And it should have propagated to switch B and switch C through VTP. So our next question, it says on switch B and switch C, verify that VLANs were added to the VTP clients. So let's do a show VLAN brief. We can see VLAN 10 and 20. Yep. Let's do a do. Oh, no, we don't have to do a do. Let's just do a show VLAN brief. Okay. And we can see VLAN 10 and 20 here. Perfect. On switch A, verify that the switch is the root bridge for all VLANs. Okay. Let's do a do show spanning tree over here so we can see all of the VLANs. And for VLAN 1, we see that it is the root bridge. So perfect. For VLAN 10, we can see that it is the root bridge. Perfect. And on VLAN 20, we can see that it is the root bridge. So it is the root bridge for all VLANs. So question number 5. It says on switch B, configure a priority of 4096 for VLAN 10. Okay. So let's do a conf t. Let's do a spanning tree for VLAN 10. And let's do a priority of 4096. Okay. All right. On switch C, configure a priority of 4096 for VLAN number 20. So let's go over to switch C. Let's do a configure terminal. Let's do a spanning tree VLAN 20. Let's do a priority of 4096. Perfect. Okay, on all 3 switches, verify that switch A is the root bridge for VLAN 1, switch B is the root bridge for VLAN 10, and switch C is the root bridge for VLAN 20. So let's do a do show spanning tree for VLAN 1 over here. Let's do over here for switch B, let's do a do show spanning tree for VLAN 10 over here. And for switch C, let's do a do show spanning tree for VLAN 20. All right, so for switch C, we can see that it is the root bridge for VLAN 20. So that's what we want. For switch B, we can see that it is the root bridge for VLAN number 10. So that's good. And for switch A, we can see that it is the root bridge for VLAN number 1. So all of that matches up. So on switch B and switch C, display the priority settings of VLAN 10 and 20. So we can go to switch B and C now. And we can see that our priority is configured for 4106. And the reason why it has 4106 is because it added 10 to the 4096. Same thing over here for switch B. We'll see that it has a priority of 4116, and it added 20 to 4096 to get that priority number. So which switch is the root bridge for VLAN 1? And what is the spanning tree priority for VLAN 1 on the switch? Well, we know switch A is the root bridge for VLAN number 1, and it has a priority of 32,768. But if you add 1, it shows as a priority as 32,769. So now it's asking for question number 10. What is one difference between the show spanning tree command and the show spanning tree summary command? Well, the show spanning tree command gives you basically all of the output, and the summary command is going to just give you a summary. Let's see what it says on Boson though. Show spanning tree summary displays the root bridge but does not display the priority. Okay, so it kind of just sums up the information with the summary command. All right, so last but not least, task number 5, implement MST. All right, you can minimize the number of instances of spanning tree running on a switch by implementing MST. In this task, you will combine VLANs into a single MST instance. Okay, so yeah, that works because, like I said, with per VLAN spanning tree, each VLAN has its own spanning tree topology. So with MST, you can group those together so the switches don't have to maintain so many spanning tree topologies. So that's always smart to save some resources on your switch. So it says on all 3 switches, change the spanning tree mode on these switches from PVST mode to MST. Combine VLAN 1, 20, and 10 into a single MST instance. Use number 1 as the instance number and revision number, and use group number 1 as the name for the instance. Okay, so let's go over to, let's start out on switch A. Let's do an exit. Let's do a show span, oh, not the show. Let's do a spanning tree mode MST. Spanning tree mode MST. Let's do the same thing over here for switch B. Let's do a spanning tree mode MST. And same thing over here for switch C. Let's do a spanning tree mode MST. So all of these switches now are running in MST mode. So let's do a spanning tree MST config to get into MST configuration mode. And let's do a context sensitive. All right, let's first do our instance. So let's do an instance. It wants us to use number 1. VLANs, we want to combine number 1, 10, and 20 into one instance. 20 into one instance. I think you can do it like that. Let me do VLAN context sensitive. So I think you can, yeah, you can separate them like that. So just wanted to make sure. 1, 10, and 20. Enter there. Let's do a revision number of 1. Perfect there. And let's name it group 1. Perfect. Let's do the same thing over here for switch B. Let's do a spanning tree MST config. Let's do a instance of 1 with VLAN 1, 10, and 20. Let's do a revision of 1. Let's do a name of group 1. Perfect. All right, let's do the same thing over here on switch C. Let's do a spanning tree MST config. Let's do an instance, if I can spell, instance of 1 with the VLAN 1, 10, and 20. Let's do a revision of 1, and let's do a name of group 1. Perfect. All right, now I believe you can do a show pending. So we haven't really we have to do exit to allow this MST configuration mode to take place. Right now it's just in our pending MST to be applied, but if we do an exit from MST configuration mode, then it'll actually save it as the current MST mode that's being used. So let's see here. Question number 2. Has the spanning tree priority for the VLANs on all 3 switches changed? Well, yes, it's going to change. Let's do an exit to save that on all switches. Exit, save that. And let's do an exit to save that. So we can do a do show spanning tree on all switches. Let's do a do show spanning tree here. And let's do a do show spanning tree here. All right. So it has the priority. So yeah, we can see that all of the priorities have changed back to the default of 32,768. And then this is MST number 1. So this one has 32,769. That's going to be the same on all switches, as we haven't configured any of the priorities. Right here, switch B, as you can see. Same thing for switch A, as you can see. So that's perfect. All right, it says verify your MST configuration. Well, we're doing that now. We can see that we have MST configured. All right, it says for question number 4, view a summary state of the ports on these switches and verify that MST is running for VLAN number 1, 10, and 20. So let's do a let's do a show spanning tree. Let's get some context sensitive. It says run a summary state of, let's see what the command it wants me to run for this. Show spanning tree summary. Okay. Show spanning tree summary. So, where we at? What did it want us to verify that MST is running for VLAN number 1, 10, and 20? It's supposed to show that in the... Okay. It doesn't really show me that the VLANs is running with this output. I guess it is forwarding. It says forwarding 2. Forwarding 3 here. So it doesn't really show me the output that is asking for that question. So I'm a little bit confused on that question. Let's go on to question 5. It says configure switch B as the primary root bridge for MST number 1. Okay. Let's go to switch B. Let's do a spanning tree. Let's do a spanning tree for MST1. And let's do root primary. Let's do a root primary. Okay. On switch C, so right here, it's saying configure switch C as the secondary root bridge for MST number 1. So let's go to switch C and let's do a spanning tree MST1. Let's give a root of secondary. Okay, on switch B and C, display the priority for MST number 1. So let's go to switch B. Let's do a do show spanning tree for VLAN for MST 1. Let's do the same thing over here. Switch C. Let's do a do show spanning tree for MST 1. Okay. So we can see our priority for switch B. We're saying that it is the root port, which is what we wanted. We can see its priority is 24,577. And we can see that our switch C has a priority of 28,673. So everything looks to be good. Hopefully we did all of our configurations right. This was a pretty long lab. Let's go ahead and hit grade. Yes, so we did get everything right. Here are the beginning questions that we were answering on the iPad. So I appreciate you guys for watching this one. See you in the next one.